369, and we are talking about exterior angles of a circle. I went ahead and I drew in the following angles for case 3A, 3B, 3C, and so I'm going to share with you that right now. But to be ready for today, also have like your protractor handy so we can get some angle measures. We want to try to convince ourselves that we understand some scenario that's happening. Okay, so I went ahead and I drew an exterior angle formed by a secant and a tangent. So please make sure you have something like this. It might not be perfect. In fact, because you are human, you're going to probably be just a little bit different than me, and that's all right. For case 2, draw an exterior angle formed by two secants. So those two angles specifically. And then last of all, draw an exterior angle, and intentionally in this exterior angle, we want tangents. And honestly, the best way to do this is just to pick a point and then rotate the protractor's straight edge until it just barely touches the circle and then trace your line. That's our best method for drawing a tangent line. Let's go ahead and measure those, right? And then again, pause the video at any time, rewind, go back, check on it, see if there's a way for you to review what you need to know. The reason why we're going to go back and use these, I need to know some angle measures, right? I want to actually specifically measure the following angles. So I'm going to measure angle, what should I call this? I need like a point out here. I think we've been using point P as our previous, like I saw that on the previous page, right? Okay, I want to measure angle APB, all points bulletin. It looks like I created a 35-degree angle. All right. I know it's a 35-degree angle. I have my center of the protractor on P. You can definitely see the angle corner there in the middle. I've lined up the 0-degree angle of the protractor with my secant line. And then starting from 0, I go 10, 20, 30, 40, 30, 35. It's a 35-degree angle. I'm going to pop that in right there. To be honest, though, in order for me to prove that I have a 35-degree angle, I kind of need to know the intercepted arc measurements. Maybe I'm going to save that for a minute. Do I need to come back to that? Yeah, I need to. This video has to be about that, okay? So again, at any point, pause the video, go back and rewind. I'm going to draw in the arc OA, the angle, I should say, BOA, a boa constrictor. And I'm going to measure that angle. But while I'm here, I might as well draw in the ray BC so that I can also get a measurement for that angle. All right. So measure the angle time. Angle BOA appears to be, center it up, zero it up, appears to be like a, go this way, 10, 20, 60, 70, 80, 90, 100, maybe like a 107-degree angle. So I'm going to put in a 107 on that arc. And then I'm going to do, what's this one? This one should be around, oh, it's like 170 degrees. Let me think for a minute. 167 degrees. This is about a 167-degree arc. Now, the reason why I'm 77, I'm hold on a minute. I need my brain. Come back, my brain. Yeah, it is about 167. Is that really 107? Honestly, it is. Okay, I'm having a little bit of like disconnect here because what I should be able to do is I should be able to go 167 minus 107 and divide by 2. So that's like a pause for me to think about. Like, I want to remember that relationship. It appears that this angle is about half of the difference between those two arcs. Maybe let's try it on another angle. Let's measure in case 2. Let's measure angle APD. Okay, so center it up, zero it up. This looks like about a 10, 20, 23-degree angle. Of course, you need your own angle to be your own, so you should be practicing your calculations. Don't just copy mine, make your own, do what I'm doing to measure it, and then be right. Have your own information. Now I'm going to draw in ray OD. Start at O, pass through D, longer. I'm going to draw ray OA, and I want to measure this angle. And I drew the line longer so that I know that I could actually see that line cross the actual arc of the protractor. So drawing this in, it looks like I'm sketching a 41-degree angle, which means that the intercepted arc is 41 degrees. Do the same thing, OB and OC. Okay, measure the angle here. This angle looks to be about 10, 20, 30, 80, 83 degrees, 82 degrees. Okay, and then if you take 82 minus 41 and divide by 2, what do you get? Is it about 23? Again, human error is plausible. Last one, case 3. Let's do the same thing. In order to find, we'll measure angle P first. So I center the protractor, make sure I can see the vertex of the angle pretty much in the middle of that hole, and then count from 0, lined up with 0, 10, 20, 30, 40, 50. That's like a 50-degree angle perfectly. Okay, I'm guessing this intercepted arc minus this one is going to be 100, and then I'm going to divide by 2. So in order to get that figured out, draw in the central angle, draw in OC, draw in OA, let's measure angle COA, and then I know that because actually there's only 2 arcs, the way that this case is drawn, we don't have 1, 2, 3, 4 arcs like part B. We only have 1, 2. So I just need to measure it twice, or once, and then calculate from 360. Line up the 0, center it on the circle's center. It lined up really perfectly. And then if I look out here, it goes 10, 20, 30, 60, 90, 100, 110, 120, 130. It looks like about 132. Okay, 132. We got to do 360 minus 132 in order to get the outside angle. So 360 minus 132, and the answer that we get for that one, let's see here, 10 minus 2 is 8, 6 minus 4 is 2, 3 minus 1 is 120, 228. This is about a 228-degree arc. That's a 132-degree arc. So we should have 228 minus 132 divided by 2 equals approximately 50. All right. Now, truth be told, I'm human. I probably made a human mistake along the way, but that is supposed to be the actual exact relationship. Consider the different measurements you determined from questions 2 and 3. Look for patterns and make a conjecture about the measure of the exterior angle of a circle and the measures of the arcs that are intercepted by that angle. So I'm going to say it appears that the measure of an exterior angle of a circle, the exterior angle of a circle, is equal to the half of the difference of the intercepted arcs. So half as in 1 over 2. The difference means subtract. All right. What's happening next for us is actually getting to a formalized proof. So here's the whole thing from this one. Pause and zoom back out just so you can kind of at least see the majority of this page. Whoa, pause right there. Zoom in. Okay. Thank you very much for watching this video. Let's get ready to page 370. See you in the next video. Bye.